Hey everyone, I'm Joachim, and today I'm going to show you how to create a procedural animated falloff that's easy to retime, shape, and control directly inside of Houdini. So without further ado, let's get right into it. Alright, so we're in Houdini. I'm just going to create a geometry container. And then inside of here, I'm going to drop down a grid. I'm going to scale this grid down a little bit, and then I'm just going to add some more rows and columns. If I hit Shift W, we'll get into wireframe mode. So the first thing we'll want to do is to define a gradient. We'll be designing the system so that we can use any type of gradient. But for now, let's start by making a gradient based on our point numbers. So I'm going to create a attribute wrangle. So in the wrangle, I'm going to start by defining a gradient variable. And then we can take our currently processed point, which is at ptnum, and then we need to divide it by the total amount of points that we have. And you can get this by either using the endpoints function or by using the @numpt attribute. However, we do need to cast this as a float, otherwise this won't divide. And I'm also going to subtract 1 from @numpt. We can then visualize the gradient by just writing it out to v@cd. And now we have a gradient that is incrementing in value from 0 to 1, and we can confirm that that is the case in our geometry spreadsheet. The reason why I picked this method is just because this will always work on any geometry, and more importantly, this will always be between the range of 0 to 1, and that's exactly what we want. Next, I'm going to create some user parameters that we'll use to control the timing of our falloff. So we can do int start frame equals to a channel slider that we're going to call start frame. And I'll do the same for the end frame. And if I click this button here to the right, it'll create the sliders for us. My timeline starts on 1001, so I'll put that in. And then let's say that just for testing purposes, it'll be 2 seconds. What we then need is a variable that animates over time. And we'll use this to move or push the gradient over the surface. This variable will be based on our current frame, but remapped to 0 and 1. I'll create a new variable called A for animation. And then we're going to want to fit our current frame between the start frame and end frame, but remap to 0 and 1. I'm also going to create a ramp parameter that we can use to time remap our otherwise linear animation. And then lastly, I'm going to remap our animation to be between -1 and 1, as we don't want the gradient to be visible in the beginning. So I'm going to say A equals fit 0, 1, because we know it's already in the range of 0 and 1, and then we're going to grab our variable, and we're going to remap it to -1 and 1. So now, if we add this to our gradient, we'll see it move. So it starts black, and then it gets to white. Right now it's doing it in the reverse direction, but we can easily fix this by just flipping our initial gradient here. So we can do gradient equals 1 minus gradient. And now it'll animate in the way that we expect it to. All right, so now we have the very basics working. However, we might want to add some additional ways to shape the gradient so that we can art direct to look further. Let's start by creating a width variable. So I'm going to initiate a new variable, call it width, if I can spell correctly, like that. And then this will be a float slider. So I'm just going to go to the middle here of our animation. And then I can add this width variable to our animation. And the way we're going to do this is by doing a fit function, where we take our variable A, which we already know is in the range of -1 to 1. But we want to add the width to the lower values. And we want to subtract width from the upper values. And then we can see that something is happening when we push this width slider. But we also need to make sure that the gradient itself gets remapped into a value of 0 and 1 in the end. So what I'm going to do is I'm going to say gradient equals, and you guessed it, another fit function. So we're going to take the gradient and add the animation. And then we're going to remap it from 0 plus width and 1 minus width to 0 and 1. And then instead of adding the animation here, we can just type gradient. But right now it's in the opposite direction and it's flipping around once we hit 0.5. So let's fix that. Here we can say width equals our flipped width times 0.5. And that will limit it to be between 0 and 0.5 instead. So now you'll see that it flips, and at full width, we expect the full range. And as we decrease this, you can see that we get closer and closer to the center. And then just as a little safety measure, I just want to make sure that this never collapses to exactly 0.5. So what we can do is we can just clamp it or use the min function to say that it should never reach anything higher than 0.4999 or something. So I'm just going to go ahead and comment out some of these sections just to make it a little bit easier to get an overview of what we've done so far. So another way we can add some flavor and variation is by distorting the gradient with some noise. So I'm going to want to do this before we do our width functionality. So we can create a new float variable and call this noise. And then let's do... There's a multitude of noises in Houdini. So what I usually do is I just type in noise, and then if you click F1, it'll bring up the documentation for Houdini. And here you can find the different kinds of noises. And I'm thinking we might want something that is roughly between -1 and 1. So the O noise will be a perfect fit. So we're going to do O noise. We're going to base it on our current position. So it needs the position, the turbulence, the roughness, and the attenuation. So let's just say position plus some offset. And then we can add a turbulence of 3, and roughness of 0.5 maybe, and attenuation of 1.0. And these initial values you can play around with, obviously. They're just from memory, having worked inside of ops. And then instead of visualizing the gradient, I'm just going to visualize the noise for now. All right, so that seems to work fine. I'm going to move it back to the gradient, and let's apply this noise to our gradient. So first off, I'm going to create a new variable. Let's call it noise gradient. And here we can take our gradient and add the noise to it. But we do want to clamp this, I believe, just to make sure that it stays between 0 and 1. So this is our noise gradient, and we can mix our regular gradient and this noise gradient to control how much influence the noise should have on our final gradient. So we're going to do a lerp function between our regular gradient and our noise gradient, and then we can create a channel slider again, call it mix noise. And now if we pull this up, you can see that we're distorting the gradient by our noise. So I mentioned earlier that this rig should be able to use any type of gradient, so let's implement that as well. Luckily, there's a really handy function in Vex that can check if a certain attribute already exists on the incoming geo. It comes in a couple of different flavors, but the one we're going to use is called hasPointAttrib. So we can make an if statement, and then we can do if hasPointAttrib, and this function needs the current geometry stream, which is 0, and then it needs the attribute name that it should check for. Let's say that it should check for __ gradient, and if that's true, then let's use @__ gradient as our gradient variable instead. And then it complains here because I need to initialize the gradient beforehand. If that doesn't exist, let's just use our default gradient that we defined earlier. All right, cool. So we can check if this is working by just creating a new gradient. I'm going to do this with the mask from target, and we can just say __ gradient. That's the attribute that it should look for. And if we visualize the gradient here, we can expand this a little bit, maybe to 1.5. And now we can see that it uses this gradient instead. However, we probably don't want the custom gradient to be flipped, so let's only add that to our default gradient. So yeah, we now have a way to detect any type of gradient, and as long as it's in the range of 0 and 1, all the animation, shaping, etc. will work the same. So what you also might want to do is to apply the same logic of checking for a pre-existing attribute for the noise as well. So I've just pasted in the same logic with the has point attribute that looks for __ noise. So now we can do a attribute noise maybe. We can set this to be a float value, rename it. And now you can see that it uses this attribute instead to distort the gradient. Pretty cool. Now lastly, just to add to this, let's also create a parameter to remap the overall gradient. So we can do this in the end. So here I can just take our gradient, and then once more we can use a channel ramp, call it remap shape maybe. And now we have another way of controlling the look and shape of our gradient. I'm just going to add a little bit more subdivisions. Finally, let's just write this out to a custom attribute so that we can use it regardless of the color or CD attribute. So I'm just going to call this ffFactor, but you can call it whatever you want. So just to drive the point across, we can now, for example, displace our surface by this new attribute, or whatever we want, really. I can create a new attribute wrangle. And if we take our position, and if we add our normals, times some smaller value, times our new attributes, we'll get this displacement effect, which is pretty cool. And this obviously doesn't have to be on a flat surface like this. It can work on any type of geometry, really. So to recap, we started by just creating a basic gradient from our point numbers. And we've also seen how we can use a predefined attribute and check for it using the hasPointAttrib function. We're then creating an animation variable that is based off of the current frame. This then gets remapped into -1 to 1 in order to push the gradient from black to white. And after that, we're creating some noise and mixing in between the non-distorted gradient and the distorted one. We've also implemented a way of reducing the range or width of the gradient, and we're also able to reshape it into any shape or form that we like. And lastly, we're exporting the gradient variable into an attribute that we can use later in our network. So before we wrap up, I thought I'd just go through how I made the intro animation. We're starting on a flat grid, and then we're adding some UVs, and then I'm scaling the UVs down a little bit, and adding some subdivisions to get some more resolution on our grid. I'm then creating a gradient attribute, and this gradient attribute is taking the length of our current position, which creates this circular gradient. We're then taking the gradient and I'm just remapping it. So I'm promoting it first here to the detail level, and then we're setting the promotion method to maximum, and then I can remap it to be between 0 and 1 so that it covers the entire surface. After that, I'm adding some noise to the position, and this is animated, so it's just creating this undulating noise kind of thing. And I'm using another attribute noise to create the noise for the factor, and this will be the noise that's distorting the gradient. If we take a look here, I'm creating the factor, and this is built similarly to how we did in the tutorial, but I've just included some extra controls and stuff for the shaping. I'm also applying the noise in a little bit of a different manner than what we did earlier. So here we're just taking the width into account, and I just found that that helped keeping the noise a bit more consistent throughout the animation. I'm also branching this off here, so I'm just taking the first frame and freeze framing it so that I then can mix between the static and the animated states. And this is being controlled by that same factor attribute. I'm then taking that same factor attribute and creating a new attribute called __disp. And this I'm using to displace the actual geometry with. I'm then adding some normals and then computing some point velocities. Finally, I'm just cleaning up some of those attributes that I don't need. And then I'm just creating a null for organization. So here on the object level, I'm just object merging that geometry. I'm rendering this with Redshift. I've toggled this checkbox to make sure that we get motion blur based off of our velocity. I've added some tessellation as well as some displacement. In terms of lighting, it's a pretty simple setup, just 3 lights. I'm gonna hit render and then I'm gonna switch to clay mode so that we can see it a bit better. So the first light is just a spotlight with a gobo texture applied to it. The second light is an area light that is acting as kind of like a rim light, but it's a bit cooler, so we get some color contrast. And the third and final light is a fill light that just lights up the front part a bit more. So all in all, this is what we get. So if we jump down to the shader, I'll just show you really quickly how this is set up. The first part is made up of this rocky gold kind of material. So we have a gold material and then we have a rocky material that I got from Quixel. So these two materials then go into a material blender. And the way I'm creating the blending is by computing a couple of different curvature nodes here. So I'm multiplying that together. And then I'm also multiplying this against the factor attribute that I'm just remapping. So together it forms this. And then I'm also adding some additional details as well. So I'm taking the ambient occlusion texture and then I'm copying it. So I have one that's a little bit bigger and then one that's a little bit smaller. And by using a maximum noise, I'm just mixing between the bigger texture and the smaller texture in order to break up the repetitions. Then doing some additional remapping, and this gets added to the curvature part. So we get this. And this black and gold material gets piped into another material blender, where we have this white material as well as this emissive material. And this white material uses the same mask that we used to blend the gold, but here I'm just using it to blend between a sort of semi-white and blue color. I'm also creating another noise that I'm remapping, and this gets piped into the thin film thickness. And this is what gives these sort of iridescent kind of patterns in the shader. This then gets piped into the material blender. The way I'm blending the white and the black material is by just, again, remapping that same factor attribute. And this gets fed into a RS color composite node where I'm just overlaying some noise to break up the edge a bit. And for the emissive material, I'm doing the same thing, just remapping it to be in a different type of range. And then I'm multiplying that against some noises just to break it up a bit. And I'm also multiplying it by a curvature node. And this gets fed into the blend for the emissive material. Lastly, we have some displacement. And the displacement texture comes from that same black rock material. But I'm using the factor attribute in order to remap the displacement on each material. So for example, here I'm just shrinking the range a bit. This then gets fed into two different ramps. So one ramp for each material. So for the black material, I want full displacement. And then for the white material, I just lowered it a bit. This then goes into the displacement blender where we're feeding the same displacement texture, but just at different strengths. And together we get this. Probably looks a bit more complicated than it is, but it's just taking different materials, blending it with different masks, using the curvature, and I'm also using that factor attribute to drive the entire blending between the shaders. And yeah, that's about it. You can obviously change, add, or modify the logic of the setup to fit your needs, and as always in Houdini, there's a million ways to do the same thing. But I wanted to share the setup as I've gotten some questions about it in the past, and personally, I use the setup all the time in my work, and I found it quite useful in a lot of different projects. Thank you so much for watching. Like and subscribe if you find these videos useful. And as always, if you have any questions, feel free to drop a comment below. The working file for the intro animation can be downloaded on my Gumroad, link available in the description of this video. I'm Joachim, and I'll see you in the next one. Bye.